Hi, everyone. Very excited to be here, especially in Seattle. It's nice to see such a big audience talking about cloud computing. So today, I'll be talking about how AI is being integrated in everyday products, right from what Amazon is shipping, but also from the millions of developers that AWS has. I'm going to walk through how some of them are actually integrating AI into their applications to build some really cool applications. So this talk is less about explaining all the features that each of the products that AWS has, more about how our customers are innovating using the AI technologies. So in Amazon, we have thousands of engineers focused on AI, right from fulfillment and logistics. So when you click on buy this product from Amazon, underneath the cars, right in terms of fulfilling the order and so forth, we are actually using algorithm to predict when we will actually be able to ship this. And even the aspect of packing, right? Like in the fulfillment center where we are fulfilling the order. Earlier, it used to be that we had these racks, long racks, where the FC associates used to be walking and actually picking up the items. Instead, now we have segmented these racks into tiny racks with robots using computer vision and deep learning. So that they can move the racks to where our associates are, so that we can actually fulfill the order faster. Similarly, even when it comes to prediction of whether a product is available on stock or not, all these are machine learning driven. The other one, if you go to Amazon.com, when it comes to searching product, discovery, personalization, all these are actually using machine learning algorithms. 2-3 days ago, we published a paper on 20 years of personalization in internet computing, where around 1996, Amazon actually, when we were just, the whole world was learning how to build websites, we were actually using a machine learning-driven recommendation system. In terms of what are the books you would actually want to read. So nowadays, we are using deep learning-based systems to personalize the Amazon experience and so forth. And the other one is to improve existing products. So Amazon actually has a wide variety of products, right from books, which is what we are known for. This is all around things like, in Kindle, we have a cool feature called X-ray, where we can actually use natural language processing technology that shows, for instance, extracts entities Khal Drogo, for instance, and then highlights it and shows context on what are all the things where they appear. And the other one is, it's a cool feature we call, again, X-ray in Amazon Instant Video. So if you have used Instant Video, I really love this feature, where at any given frame in a video, you'll be able to pause it. And again, using computer vision techniques, we can tell who are all the actors in a given frame. So any debate I have with my wife saying, is this the same actor who appeared in that TV show? It can be solved instantly, because we also have an IMDb link to that actor. So again, we are not doing this by having thousands of annotators looking at each and every frame and saying, hey, this actor is that. We are running through computer vision deep learning algorithms to do this. So, and then the new kind of products, this is the promise of AI. We are actually enabling products that were not even thought of. In addition to just enhancing existing products, such as Alexa. I'm sure many of you have Alexa at your home. So in my household, Alexa is I have a 2-year-old at home. She actually calls out Dad, Mom, and Alexa. So that's so she doesn't even wait for me to play her Wheels on the Bus song. She just goes to Alexa and then says, Alexa, play this. Yeah, not in that order, actually, that is true. So, but when you unpack what is behind Alexa, so Alexa is not just about a speaker. It is years of research that we have put into the deep learning-driven automatic speech recognition and natural language understanding, so that we can actually understand the speech and also understand the meaning behind it, saying when someone says, play this music, we understand the intention is to actually play something and then call a backend API that can actually stream a music and so forth. And Alexa has evolved also to be smarter, where we have put in a deep learning model where we can actually even tell you, for instance, whether echolook is in computer vision combined with ASR and NLU. And we can also have video calling capabilities as well. All these are like examples of like new products that are possible with actually some of the advances in AI. The other final one I'll highlight is Amazon Go. So Amazon Go is in a checkout-less retail store experience, no wait. The store will be something like this, where you walk in and scan your phone when you enter. After that, you can walk around, pick up anything you want, and walk out. I kind of joke that it's like shoplifting legitimized. So except we know what you took, and we will bill you for it. I guarantee that. So, but when you unpack again what's going on here, it is using computer vision technologies so that we can actually see what a person is walking towards, what they are picking up, what they are putting back, and so forth, so that you can actually build a new kind of retail store experience that was not even possible to be dreamt of before. So with that, you might be thinking, hey, sounds like the future is already here. Why is like retail stores not more awesome? Or why is actually everything doesn't have like what the X-ray capabilities or what? And the problem is, I mean, building these artificial intelligence systems is actually kind of not so straightforward. So again, to build these AI systems, you need a lot of data. And you feed those data into the algorithms and in a process called training. And then eventually, you build the what is called as a model, where the trained algorithms say, hey, when this input comes, you got to predict this output. So that's called the prediction aspect. So the challenge for AI historically is all around scale, where for data, you need like huge amount of data to build these algorithms. And the advantage, what I have seen, and I'll talk about some of the customers, is that they are already in the process of moving a bunch of this data. So they are able to actually derive value out of the data that they are moving to the cloud or creating on the cloud. And these algorithms, and many of these algorithms, especially like deep learning neural nets, papers were written about them even 2 decades ago. So it's not like they were, to a large extent, invented only in the past 4 years. But what has accelerated the adoption of it is that we have specialized compute infrastructure, such as GPUs and even optimized CPUs and FPGAs, you name it. And we have those available in AWS, and so that you can actually build an elastic training system if you want to train these algorithms. And we also have, after training these algorithms, you can run these prediction models on top of instances or on top of serverless infrastructure like Lambda and so forth. Or you can run it on top of like edge devices. Like one of my team members, he actually built a wine detector using a deep learning engine that my team works on called MXNet, where you can point the Raspberry Pi camera at a wine cellar, and it can tell you what are all the wine labels in there, so for instance. Well, the future is already here, but the problem is it is not evenly distributed. So it's because even today with machine learning, you still need extensive amount of knowledge when it comes to like how to use these machine learning. They will throw you, when you talk to these scientists, they will explain like, oh, you got to set the learning ratio, you got to set the backpropagation metrics, and then you got to tune the hyperparameters and so forth. So I kind of joke that the way machine learning world is where databases were when we just invented B trees. We didn't even have a query language, let alone a query optimizer. So that's the kind of world we are in right now. And my job is to actually build new set of capabilities called Amazon AI. These are intelligent services powered by deep learning infrastructure. So as I mentioned, in AI, there are actually, one of the challenges we are seeing is there are different level of expertise with respect to machine learning and understanding these algorithms among different developers. At the core layer, there are actually machine learning scientists who are extending the core machine learning algorithms to, let's say, handle sparse data or to actually support new kind of neural net formats. Those are the folks who actually want to say, give me a really extensible AI engine or deep learning framework that I can play with. And then there are data scientists who are saying, I have these data stored in cloud in, let's say, S3, our storage service, or Redshift, our data warehouse. I want to build a model to do customer churn prediction or fraud detection. So for them, it is all about building custom machine learning models. And there are actually the next set of app developers who say, my job is to do visual search. Don't tell me to go take a course for 6 months on machine learning. I have other things to do. So I'm an app developer. So help me actually provide a serverless API to get this going. So the way we think about it is each of these are different set of customers, and the services that they want are very different, and the abstractions they want are very different. So that's why in AWS, we have different set of capabilities, right from at the top layer, we have services catered towards computer vision called Rekognition. And then we have services to convert text to speech. And we have services for building conversational application. And then we have, in the next layer, what we call as platforms. We have services to do things like building custom machine learning models. And we also support all the deep learning engine frameworks, right from like Apache MXNet, which Amazon has heavily invested in. But we also have optimized support for Caffe 2 and Caffe and TensorFlow, Theano, and so forth. So in this talk, what I want to do is talk through, like we launched many of these capabilities last year. And I want to talk through how some of our customers are using it. So to begin with, we have a service called Rekognition, which is doing object and scene detection. I'll just quickly show you context so that you know what's going on. So here, given an image, we can tell what are all the interesting things in an image, right from there is a person walking on a skateboard. And then the instance, we can say there are cars, and there is a tree, and so forth. And we can also do facial detection. Given a face, we can actually tell attributes like is the person happy or smiling. And we can also even guess the age range, for instance, and so forth. And we can also do facial search. So given a database of faces, when you send a new face, you can actually say, hey, what are all the similar photos of the similar person here? So that's Rekognition maybe in like a nutshell in terms of what we are doing. But let's see how customers are using it today. One of the interesting use cases is C-SPAN. So C-SPAN actually built an application in a matter of 3 weeks to index all their video archives. So, and again, using Rekognition, so they were able to detect up to 99,000 people so that they can say, hey, show me all the videos of this senator when they were actually doing a briefing. Earlier, they used to be indexing with a lot of manual annotations where somebody was carefully annotating, saying, this briefing, we had these senators participating in it, so that they can go back and retrieve it. Now, instead, they are able to save 9,000 hours a year. I mean, think about it. I mean, this is actually incredible for human productivity, using actually a combination of Rekognition where they were automating the footage tagging. That's quite interesting. The other one is Washington County Sheriff. This is actually, they usually receive more than 300,000 photo leads within 1 to 2 days for identifying persons of interest. And typically, this identification process takes anywhere from like 2 to 3 days. And using Rekognition, again, these are app developers who do not know anything about machine learning, let alone deep learning or ResNet or so forth. They actually were able to build a software that brings down from 2-3 days to 1 to 2 minutes, greatly increasing the ability for law enforcement to act quickly when they get any kind of new information. So within 1 week of going live, the solution identified a suspect for a cold case. That led to an arrest with a due process. So this is, again, incredible when you think about like the power of these AI services that has in the hands of developers. So the other one I want to quickly talk about is Polly, which is our lifelike speech service. Given the time, I didn't actually want to do a short demo. But think of it as Polly is basically text in, speech out. It can handle 24 languages. It can speak in 47 voices. And it is used for various use cases. One of the examples is Duolingo. So Duolingo is a high-quality language education application. It's actually pretty cool. And they have more than 170 million users. And it's probably the most popular language e-learning platform. So there, again, one of the interesting things is they want each lesson targeting different linguistic styles. So it's not like they are settling for a robotic voice that reads a particular language. They want to customize the linguistic skills and concepts. And they were able to do that with Polly so that they can automate most of their speech synthesis. And Polly has been used also in other cases. Other one to highlight would be like Royal National Institute of Blind, that has more than, which is a nonprofit supporting visually impaired, and millions of them. And they are using Polly to generate audiobooks for multiple languages. Again, other cool thing about Polly is we don't restrict if you generate a speech. You don't have to call us again every time you want to play it. You can just generate the speech once, save it as a media file, and actually redistribute it as you wish. So now the other thing I highlighted was app developers with Lex. So Lex is a conversational application service. So think of it as Lex is literally what is inside Alexa. So that's why you are very creative in naming it by dropping the A on both sides and calling it Lex. So Lex, what it enables you to do is like kind of build an application where how your users will be able to interact with your application. So right now, when you are trying to build a travel app, you're basically asking your users to click, swipe, or type to saying, like, check out all the parameters and whatnot. Using Lex, they can actually talk to it by saying, I'd like to book a hotel. And it'll say, OK, now I understand you're trying to book a hotel. And then it'll ask a follow-up question saying, like, hey, I need a destination. So let me ask a question. And then when they say, now tell me when you would like to check in. And again, you can say next Friday. You're not giving it any specific date format or anything. You talk to it like a normal human. Talk or type, again. And this is Lex kind of in a nutshell. And it integrates with mobile app, web app, and so forth. And also with Facebook Messenger, Slack, and so forth. So when we launched Lex, and we made it generally available like 2 months ago, I think. So we had like very, very interesting use cases. For example, Freshdesk. They actually combine Lex ASR and NLU capabilities to automate a bunch of the customer service use cases so that users can transact using natural language. So that, and also customer support agents can make intelligent decisions to enhance customer experience. Then the other, super interesting use cases like American Heart Association. They have more than 300 events annually in the US, and they are using Lex to actually make the registration very straightforward for non-tech audience. Who actually want to talk to or type in a very natural language. So that's some of the examples of like app developers building like innovative AI applications. Then let's go one level down with examples of how data scientists and machine learning scientists are doing. So here we have Amazon Machine Learning service, which lets you build predictive model in a matter of minutes. And I will actually talk through some of the examples of how we are enabling scientists to build deep learning and machine learning models using AML service and also our deep learning AMI, which is our machine learning image, that comes pre-bundled with all the popular deep learning frameworks, or I shouldn't say all the popular, some of the most popular deep learning frameworks, and make it easy for you to train and build these models. A good example would be Mapillary. It's a computer vision for crowdsourced maps, and that uses deep learning on Amazon. So they are able to build accelerated training using P2 instances, and they applied their fine-grained computer vision algorithms using that. The other one is SIGOT. They actually, when I talked about like some of the nitty-gritty details of how to build a deep learning model, one of the things is around like, how do you, let's say, tune these models? Because they come with 1,000 parameters. So SIGOT has done some really innovative work in model optimization. So this is catered towards data scientists who do not have to deal with all the nitty-gritty aspects of model optimization. And SIGOT is built using some of the stuff what I talked about to build improved accuracy and lower training costs as well. So, and they have cut down the computation cost by 8x or more compared to traditional optimization methods. Now, say the promise of deep learning is like take an input in and actually produce an output similar to like understanding speech, recognizing what you see, or also even detect things like, is this transaction fraud or not, or is this customer happy or not, or so forth. So it can handle all the way from image, video, speech, and various other medium. Now, in AWS, again, similar to how we have been doing across for the past decade or so, we are pretty open with respect to supporting all the frameworks. And internally, we have actually used MXNet as an example for many frameworks. And I want to just highlight, instead of just showing everything, what AWS is doing. Like one of the AWS customers called Too Simple. Too Simple is an autonomous driving car startup where they are probably have one of the world's best autonomous driving model today. And this is an example of how they are using MXNet to do things like identification of, let's say, objects and tracking of a vehicle, and on different conditions. This shows during the nighttime. The other one shows during the daytime, for example. Again, the key aspect when it comes to MXNet, at least the reason they picked is because it's not because we optimize and we recommended it. It's because they tested it across a wide variety of sources and across and when you're training across petabytes of data, in this case, like videos and so forth, being able to build these models and train them, not in days, but hours, actually matters. So it saves them in terms of the actual computational costs, but also in terms of speed of innovation, so that they can fix the possible areas where they want to improve their model accuracy quickly. So the other example is like 2Sense. It's in biometrics for mobile devices. They are using, again, MXNet as an example to do things like determining, for instance, identification of behavioral biometrics and so forth. So I'll also briefly talk about like some of the areas where we are using deep learning frameworks at Amazon, right from core, as I mentioned earlier, right from like applied research, Alexa, demand forecasting, and so forth. All of them are actually using some of the deep learning frameworks that I talked about, like MXNet and so forth. So we have a lot of innovation going on, but it's not just Amazon. So in AWS, when I actually was asking the teams, saying like, hey, build a slide that kind of shows what are some of the AI workloads running on AWS, they asked me, saying like, how many slides do you want? And then I said, okay, one is good enough. So we had to actually kind of restrict it to some sample set. But again, what it shows is that with the choice of cloud platform, I mean, even the deep learning algorithms were probably the first deep learning paper were written like 20 years ago. With a combination of wide variety of compute infrastructure and then a combination of wide variety of data infrastructure, if you see the breadth of storage and data analytics offerings that AWS provides, we are able to actually enable so much innovation by these customers so that they can build their deep learning models or machine learning models that create these wow experiences for their customers. I mean, that's why I'm super excited about what the future will be in this space. Thanks again for the opportunity. Thank you.